So as I said, this is our last live online class. We're going to be covering some reviews. I mean, it's not our last one. I mean, our last one is going to be Thursday, okay? But this is our last full week of live online classes. Okay, so what we're going to be doing this week is we're going to be going over a practice exam, like practice problems for our final. Okay, so this week we're going to start today with doing maybe the half that's related to properties of functions and differentiation. And next time when we meet on Thursday, we'll go over integration and some applied problems at the end. Okay, so this week is our last week of live online classes, and the week after, the week that starts, I think, on May 16th, is our final exam week. Okay, so let me start by sharing my browser. Okay, and I'm going to go over to Chrome and share the course with you in a minute. Okay, so here we are in week 16, week 15, rather, complete by May 16th. That's Sunday. Okay, and you can see it's all practice for the final exam. There is a grade check assignment. This is our last chance to kind of communicate with each other about how you're doing and what kind of support I can provide for you. As I mentioned, there is this extra credit opportunity that if you decide to take it, you can earn up to 5 extra points on your final, and those are 5 points that are added to the grade on your final. Okay, so no funny business, 5 points is 5 points. Up to, okay, you have to take a quiz in order to earn that, but this is kind of a fun thing to earn extra credit with because it's not doing math, it's learning about how other cultures think mathematically and how they use it in their everyday lives. So I think it's pretty cool. And again, no computation required. Okay, our final exam week, which is next week, you'll notice there's no live online sessions in here. Okay, there's just the final exam work. And again, the due date on this is May 18th, which is Tuesday. Okay, so again, try to consolidate all of your information this week so you're fairly ready to take this exam early on in the week. Okay. Again, I'm sure some of you are taking other classes and you have assignments due for those. So the sooner you get this done, then the class is pretty much complete. Okay. Before we move on to anything, I want to ask any questions about scheduling. Okay, anybody have questions about scheduling, what's due when, how to do it? Anybody at all questions about how the course is going? Okay, there isn't much time left. Okay, if you have concerns, by all means, please reach out to me with your concerns. Okay, you guys, the guys that are on this call right now, in this meeting, you guys are the ones who stuck it out. You made it through. Okay, so there really isn't much else to do, okay, except to do the final and grade check. I mean, that's pretty much it. If you want to go back, like I said, the first 8 weeks of the course are still open, wide open. You can work on those assignments anytime you want. Anything that's a Canvas assignment, like a discussion board or a grade check, those are also still open. If you're interested in working on homework from the second 8 weeks of the course, weeks 9 through 15, you're going to need late passes for those. Okay, but everybody should have a ton of those. Okay, I'm looking and not too many people have used up most of their late passes. Okay, question is how many questions are on the final exam? The final exam is pretty similar to all the other exams. Okay, in that there are about 20 odd questions on it. Again, if I open it up, it should tell me information about things like that. So I'm just going to open it and take a peek. Okay, so no worries. Okay, let's see what I can get it to do, if it does anything. Okay, just so you know, things have been pretty slow. Okay, so you have 2 hours to work on this. Okay, so you have 2 hours for the whole exam. It's got 100 points, which lets me think that there are probably 20 questions. Okay, I'm going to peek at it really quick and slide all the way down. And again, you can see we've got 15, even better, 15 questions. Okay, so there you go. Okay, so 15 questions in 2 hours. Okay, everybody all right with that? Okay, please, please do me a favor and try to write down your work as you go. I know a lot of these questions are things you can do completely with a calculator, but if you can actually show me something here once you're done with the exam, like submit the exam and then take photos of your work. There are apps that you can get for free that will take all your photos and put it together in a PDF. You can just upload that if you want. Okay, so it wouldn't be at any cost to you to do that. Some of you I know have scanners and you scan it in, but you know, if everybody has a way to show me work, that'd be great. Okay, any other questions before we move on? I want to make sure everybody's comfortable with what we have left. Other questions? Okay, not seeing any. So what I am going to be using is this final exam practice. Okay, if you print this off or you look at it online, it's got a bunch of review questions and then it's got solutions in the back. Okay, but it's just solutions and that's not helpful because you don't know how the solutions were gotten, right? So I'm going to open this up briefly, show you what's in it. Again, hopefully I'm getting the right pull down. Okay. All right, so here are all of there's a lot more questions in the review than there are on the exam, right? And then here are the answers. And I wanted to show you this. There's also some formulas, okay? It says these will be provided on the exam, but you know what? I'm not using a lockdown browser, so you can open up anything you want, okay, for this exam. If you want to open up this review sheet, okay, you should be able to see these formulas, okay? Okay, with what you have access to on the exam. Okay, bad enough it's timed. I'm not going to restrict what you can use, okay? Timed exams online are stressful. Believe me, I understand. I've taken my share of them. So here you have whatever you need. Okay.
Where exactly did you identify this formula sheet?
Okay. It is in week 15.
Okay.
See right here, it's final exam practice. It's just it's the note sheet that I am going to be doing today.
Okay.
And on Thursday, and the formulas are all the way at the bottom of the note sheet. Okay. And again, feel free to make your own note sheet. I'm sorry, I'm having a little trouble with all the slider bars here. Okay, let me see if I can get down there again. Solutions, and then you've got them afterwards.
Okay, thank you very much.
At the bottom, yeah. Okay, stuff you need to know. Okay, and again, I've also pointed out all of the shortcut rules. You have these in Canvas. Okay, I've given you a derivative cheat sheet, an integration cheat sheet. What I guess I'm telling you to do is, by all means, bring up whatever questions you have on the review, in the review sessions today and on Thursday, but make sure you collect all this stuff so you have it handy at the time you're taking the exam. Don't just take the exam cold. All right, get all this stuff together, like all of this cheat sheet stuff. It's all in there, okay, but you need to find it and have it handy. Okay. All right. Okay, so I am going to open this file and again, share it with you and write on it. And then what I'll do is I'll upload my notes like I usually do along with the recorded video. Okay, so just give me a second to get this set up. Okay, and let me share the content with you. All right, everybody should now see final exam, Math 213 final exam practice. Okay, and I don't know if you noticed, but when I opened the final, the first question on the exam was just like this one. Okay, it was all about limits. Okay, so this exam, the final, and this is a decision made by the math department, not my decision. Our final exams tend to be cumulative. That means they cover all the material that's taught in the course. It's not just the last chunk since the last exam. Okay, the reason for that is if you go forward mathematically, like doing other things that involve calculus, say to take Math 218 or some other course later on in your academic life, or even if you're using this somehow in say financial modeling later on in your career, you need to be able to make everything work together. Okay, so basically it's an opportunity to see how everything works together. The other thing that I am going to do, and I'm not sure it's officially in my syllabus, what I typically do at the end of the course is I'll go back and I'll replace your lowest exam score with your grade on the final as long as it's higher. Okay, so this gives everybody the opportunity to say not do well in one exam. And as long as you get stuff together by the final, I'll replace that low exam grade, right? So for example, you could have like an 85, a 92, a 60, and an 87. And let's say you get like a 90 on the final, I'll replace the 60 with a 90. Okay, so there's a chance you can get a good grade in the course. Okay, everybody all right with that? Replace the lowest exam grade? Anybody have questions about that? Now, some of you have not taken one of the exams. Okay, so by default, that will be the exam I replace. Okay, so if you haven't taken an exam, okay, that will be the lowest exam score, and I'll replace that. Okay, and again, it takes me a while, just so you know. Once you take the final exam, it takes me about a day to go through and regrade them all with your work. And then it takes me additional time to go back and make sure I do the replacement correctly. Okay, so I will definitely email you as soon as I have final grades in Canvas. Okay, I'll email you when the grades are ready. Okay, I'll email you when final grades are posted, but give me some time because not only that, it's not my only course. Okay, I have to do this for 4 other courses, so it's going to take a bit. Okay, so as I said, I would encourage you. I did take out exam 4. Exam 4 is gone. Okay, exam 4 is gone. I'm talking about the other 3 exams. Okay, I'll replace one of those as long as your final exam score is higher. Okay, yeah, exam 4 is no longer in the course. You can't find it anywhere. All right, any other questions? Okay, so again, this gives you the opportunity because calculus for most people, the first time they see it is not intuitive. So it takes some time to get the hang of what's going on. All right, so this gives you the opportunity to still do well in the course, as long as you understand it well enough to do well on the final. Okay, so let's get into that. All right. This is all about limits. Okay, so I'd encourage you as we go along, ask questions. And if I ask you to participate, please participate. Okay, thinking about it and coming up with an answer yourself is a lot more valuable than watching me do it. Okay, you can watch me do it for a long time and still not really understand what's going on. Okay, so let's go and look at question 1. We have a graph of a function that looks like it's been run through a blender. There's lots and lots of discontinuities in this function. Okay, but again, they're calling it f of x, and they're asking us for various limits. Okay, now again, what do you have to remember about limits? Okay, limits are not the same thing as function values, right? So let me ask you this question. How is the value of a limit different from the value of a function? at a given x. I'm asking you for some input. And again, feel free to unmute and talk. How is the value of a limit different from the value of a function? Anybody have any thoughts? Okay, must two same. Must the two be the same? Anybody? Okay, we've got 14 people on. Okay. Okay, we have one vote for yes. Okay. Anybody else have any ideas? Thank you for volunteering an answer. I appreciate that. I know it's kind of scary to put yourself out there when you might not be right or wrong, whatever. So I appreciate when you do that. Okay, we have one that says no. Okay. So see that, guys? We've got one on each side. So the rest of you, what do you think? Right? Not seeing anything else. No, they don't have to be the same. Okay. No, two more no's. Okay. Okay, so let me answer the question, I guess. Okay, and try to pull the threads together. Okay, a function value and the value of a limit at an x value are the same provided the function is continuous there. Okay, so for example, okay, there's no value in one of the questions here, but if I wanted to know what is the limit as this function approaches -4, okay, you can see it's approaching y equals 0. I'll say it's 0, even though it's off a little. And the function value at x equals -4 is also 0. So that's an example of where the limit and the function value match. But the function's continuous there at that x value. All of these questions deal with the points of discontinuity. Remember the, I guess, rule of thumb, okay, not the mathematical definition of continuity, but a discontinuous place in a function is where if you were drawing it, you'd have to lift your pencil. So here's a discontinuity right here at -2. It's real likely the limit and the function value at that point are not going to be the same. Okay. Here's another discontinuity at x equals 0. You can see the function's heading off to infinity in this direction and -infinity in that direction. If I were drawing this, I'd have to lift my pencil across the discontinuity to draw the other half. Here's a third discontinuity, right, at +2, where there's a hole and a function value up here. All right, so this particular graph is showing 3 discontinuities, and it's likely the limit and the function value will not match in those places because one of the criteria for continuity is that the limit and the function value at every x value match. Okay, so it's kind of a relationship between limits and functionality. See the relation between limits and continuity. Okay, see the relation between limits and continuity? Okay, so let's take a look at these questions, okay, and see if we can answer them. Okay, first let's review the notation. This says the limit as x approaches -2, and this negative sign means from the left, okay, from the negative part of the x-axis. So I'm approaching -2 from the left. Okay, what y value am I getting close to? Well, you can see, even though the function is not, there's an open circle here, I'm getting closer to the y value 2. So I'm going to put 2 here. And the second question, part B, is saying, what is the limit as x approaches -2 from the right? See the plus sign? That means from the positive side of the x-axis. So here's what's happening here. And you can see I'm approaching the value y equals 0. And that's also the value of the function right here. Okay, see the filled in circle? So this function is actually defined, okay, at -2, and its y value is 0. But there's this discontinuity, this jump. Okay, so I'm going to basically say 0. Okay. Now, what you would also know is, does the limit as x approaches -2 exist? So I'm asking you a question that's not on the sheet. Does the limit as x approaches -2 exist? I have it from the left side, it's one value. From the right side, it's another value. So does the limit, here's what I'm saying. Okay. So does this exist? You know, plus or minus, right? Okay, so I'm getting a bunch of no's, and you're correct. It does not exist because the values of the limit from the left and the right side are different. Okay, so I would say this limit does not exist. The function's defined at -2, its value is 0. Everybody see that? So here's an example of the limit not existing at a given x, but the function value does. Okay, and again, any mismatch will happen where the function is discontinuous, where there's a discontinuity. Okay, now let's look at approaching x equals 0. This says, what is the limit of f of x as I approach x equals 0 from the right? That's here. Okay, I'm getting closer and closer to x equals 0. Okay, but I'm never going to reach it because this goes up forever. So I would say this is infinite. Okay. If they asked you for the limit as you approach 0 from the left, you would say -infinity. Right? But what they ask instead is, does this limit exist? Okay. And I would say it does not exist. Okay. It can not exist for one of two reasons, right? First of all, the left hand and the right hand limit are both infinite. Okay, that's like saying no limit, right? And they're different. Okay, but even if these both went in the same direction, we would still say the limit doesn't exist because I'm not approaching a value. Okay, I keep getting larger and larger or more and more negative. Right, the last one is the limit as x approaches 2. Okay, so first let's check from the left. We can see as we get closer and closer to x equals 2, I'm getting closer and closer to y is 1. Same thing over here as I approach it from the right. As I get closer and closer to x equals 2, my limit, my value is getting closer and closer to y equals 1. So the limit as x approaches 2 is 1. Is that the function value? No. If you take a look, the function at 2 rather, is not 1. Okay, it's 3. Okay, so f of 2 is 3. It's not the same as the limit. Why is that? There's a discontinuity here, a hole. Okay, is everybody okay with question 1? Anybody still have anything that's not quite settled about limits? Okay, why is it 1 again? Okay, I'm trying to think of what it is. Why is the limit 1? Okay, the limit is 1 because as you travel down the curve from the left towards x equals 2, it's the y value you're getting close to. Okay, it's the y value you're getting close to. Okay, same thing as you travel down the curve towards x equals 2 from the right. You're getting close to y equals 1. Okay, it's just that right at 2, okay, the function value is different. Okay, so the limit is talking about the y values you're getting close to, right? Here you can see you're getting close to 2 different y values, so there's no limit. But here, when you've got a whole just taken out like this, the limit will exist. Okay, any other questions? Other questions? This is a chance to get your questions answered. Okay, or if you want to pose another question, like what about this? All right. A lot of the next set of questions, believe it or not, have to do with college algebra. Okay, so get ready for a college algebra review. Okay, these are not technically calculus questions, but they're important, okay, if you're going to understand how limits work and where a function's differentiable and all that stuff. Okay, so here, okay, what kind of a function is number 2? What kind of function is this? Anybody know what family it belongs to? Okay, you can see the symbolic rule for it, so that should help. Again, what are your choices? Polynomial, exponential, logarithmic, radical, rational, you know, those things. What family? Okay, yes, it's a rational function. How do you know? Rational functions are quotients of polynomials. Quotients of polynomials. What's a quotient? Something that's divided. Okay, so you have a numerator and a denominator. Rational functions have domain restrictions, right? Can't let the denominator be 0. Remember that? Can't let the denominator be 0. The function would be undefined there. Okay? So there are certain families of functions where you have to worry about restrictions on your domain. What families of functions are there that you have to worry about it? Okay? Okay, worry about domain restrictions on rationals, radicals, okay, I'll say square root, even roots, but I'll say square root, okay, and logs. Okay, worry about domain restrictions on rationals, square roots, and logs. Okay, no domain restrictions on polynomials, exponentials, no domain restrictions. Okay, they have all real numbers as inputs. Okay, so here, since it's a rational function, I have to worry about what to take out of the domain. How do I do that? I take the denominator and set it to 0, right? And then I just do a little bit of algebra, add 1 to both sides, and then divide by 2. Okay, so kick this out of the domain, exclude this. Why am I excluding it? Because I just determined it makes my denominator 0. Okay, so a domain statement in interval notation, which everybody should be comfortable with by now. Okay, here's how you exclude one value. Start at the leftmost negative end of your x-axis. Okay, what's out there? Well, that's headed towards negative infinity. Okay, whenever you do an interval, the low values on the left, the high values on the right. Okay, now I'm allowed to feed this function any real number, okay, any negative real number, okay, all the way up to and including 0, up to positive 1/2. Okay, I have a curved bracket, a parentheses here, because I am not allowed to include 1/2. Okay, if 1/2 were included, this would be a square bracket. Okay, I can also feed it any number just to the right of 1/2, not including it. See the curved bracket? All the way out. Okay, so basically any real number here or any real number here. And remember, you put a union symbol to say or. Okay, so this shows you a hole in the domain. Okay, I've left out 1/2. Okay, that's what a hole looks like. Okay, now as far as the range is concerned, okay, you can graph it to tell the range, okay, or you can basically look at it and decide where is your horizontal asymptote. Okay, it's probably easier to just graph it, okay, and look at the range. Because again, remember what these graphs tend to look like. They tend to look something like this. Okay, so they have a horizontal asymptote and vertical asymptotes. Okay, and that's going to decide, you know, what you leave out of the domain and what you leave out of the range. Let's graph it so you can see. I'm going to go over to Desmos. Okay, and I'll put this up here as y equals 4x plus 1 divided by 2x minus 1. Okay, so I put it in parentheses to make sure I have it correct. Right? And again, you can see I have a vertical asymptote at 1/2. The function shoots off to positive infinity on this side and shoots off to negative infinity on this side. Right here would be 1/2. Okay. And then if you look at the function this way, it looks like it has a horizontal asymptote of y equals 2. Everybody see the horizontal asymptote? Okay, see the horizontal asymptote? Again, you can get that by looking at the degree of your numerator and denominator. These match, they're both linear. And if they match, the degrees match, you just look at the ratio of leading coefficients. 4 divided by 2 is 2. Y equals 2 is my horizontal asymptote. So I technically didn't have to graph it, but it's real easy to see on Desmos. Okay, so you can tell that the y values of this function, okay, I have any negative y value you want up through 0, getting close to 2 over here. And then I have any positive value of y just to the right of 2 on up. What value am I leaving out? I'm leaving out 2 from the range. Okay, leave out y equals 2 from the range. Everybody see that? Okay, everybody see why you're leaving out y equals 2 from the range? Okay. Anybody questions? All right, so I would basically go over here and I would say my range is, it's a good idea to label these things. Here's D for domain, range. And again, the range, if you're assuming it's a range, then you know these are y values or f of x values. Negative infinity up to and not including 2. Just above 2 all the way out. Okay, leave out y equals 2. Okay, horizontal asymptote is right? And here I had vertical asymptote is x equals 1. Okay, so these rational functions are functions that have asymptotes. Okay, your y-intercept, okay, that's a graphical question. Again, you can find it from the function rule, but if you want to graph it, you can see it right over here. Okay, it's 0, -1. If they ask us for a horizontal intercept, it's -1/4, 0. Okay, so just do that graphically. Okay, and again, I've already got my vertical asymptote and my horizontal asymptote. Okay, I needed these to answer these questions. Okay, everybody okay with number 2? Okay, anybody have any questions? Again, a college algebra question. Okay. Okay, so this is a college algebra question, probably something you would need to solve some other type of question, okay? The rest of 3 through 6 are finding limits algebraically. Okay, is there any rule that says you can't graph these? Of course you can graph them. Of course you can graph them, okay? Now, if you take a look at this function, okay, what kind of function is number 3? What kind of function is number 3? Again, I'm asking what family of functions? Polynomial, okay? Any discontinuity in polynomials? Any discontinuities in polynomials? I'll show you how knowing something about continuity and limits will speed up the process. No, polynomials have no discontinuities in them. Okay, they're nice and smooth. Okay, so again, what kinds of functions have discontinuities? Well, rational functions, they've got asymptotes. Okay, piecewise functions, anything where you've got holes. Okay, and that's pretty much it. Okay, as far as continuous where they're defined. Okay, so this is a polynomial function that I don't have to worry about continuity. So I know for every point in this graph, okay, the function value will equal the limit. Okay, so function value equals limit everywhere because it's continuous. Everybody understand that? So because of that, all I need to do is plug in -1. Okay, do this and evaluate it on a calculator. Okay, this is going to be 3 plus 6 is 9 plus 9 is 18. Okay, so the function value and the limit will be the same everywhere in a polynomial function. Okay, you'll notice all the rest of them are rational functions. Okay, so 4 through 6 aren't so simple as their rational functions. Okay, so again, what I'm trying to show you is how to decide where to spend your time. Okay, these are rational functions, so I need to do a little funny business. Okay, now for example, if you look at this function, it might be worthwhile to see if I plug in a -3 here, will my denominator be 0? So this will be -3 squared, that's +9, Negative 3 times 2 is minus 6. So that's 3 minus 3. Yeah, plugging it in won't work. Gives a 0 denominator. So I have to do something else. Okay, and usually what I'm going to try is some kind of algebra. Okay, now I'm looking at something that's got a polynomial in the numerator and a polynomial in the denominator. Okay, there is a polynomial factoring app in the course. Okay, there's a polynomial factoring app in the course if you're not comfortable doing this by hand. Your numerator here factors into the difference of squares. Okay, that's what gives me x squared minus 9. And the denominator, I know I have an x in one term and an x in the other term to give me x squared. The last term is negative, which means one of them's plus and one of them's minus. That's the only way I get a product term of negative 3. There's only one way to get 3, and that's with a 1 and a 3. So I have to figure out which one's positive, which one's negative. Okay, so I need them to add up to a positive 2. Okay, that means the 3 has to be the positive one, and the 1 has to be the negative one. Okay, again, if you're not comfortable doing this, there's a factoring app. Okay, now once you do this, you'll notice there's a shared factor. In the numerator and denominator. Okay, see the shared factor? It means there's a whole at x plus 3 equals 0 or x equals negative 3. There's a whole at negative 3. Okay, now usually, if you remember from the graph, okay, that was in question 1, usually limits exist at wholes. Okay, so I don't need to worry so much about the whole. Now what I need to see is if I factor out the whole, can I plug in the negative 3? Okay, so let me see if I can do that. All right, so I'm going to plug in negative 3 minus 3 on top, negative 3 minus 1 on the bottom. Okay, so plug in what's the negative 3, which is the thing I'm approaching, the x value I'm approaching, in for x, and what's left. Okay, this gives me negative 6 over negative 4, which again, since numerator and denominator are both negative, negative divided by negative is a positive, factor out a 2, 3/2. Okay. So again, this is saying, what's the limit as I approach negative 3? Well, that's where the whole is. The limit exists there. And this is its value. Okay. All righty. Let's take a look at this one. Again, there are polynomial factoring apps. There's also polynomial multiplication apps. Okay. If you were to FOIL out that cubic, okay, you could, that basically is saying do this, h minus 1 times h minus 1 times h minus 1. Okay, and if you were to do that, you would get h cubed minus 3 h squared plus 3h minus 1. Okay, so that would just be FOILing it out. Okay, so your numerator here is h cubed minus 3h squared plus 3h minus 1 plus 1. That's coming from here over h. Okay, you can see if First of all, these cancel out, right? I have a -1 and a +1. So now I have h cubed minus 3h squared plus 3h over h. And you should realize you can factor out an h. Okay. Why did I have to go and do all this? Well, if you notice, I'm trying to take the limit as h approaches 0, and that would give me a 0 in the denominator. So what I'm trying to do is find a common factor in the numerator and denominator, just like I did with number 4. Okay. If I can get rid of the h in the denominator, then my problem goes away, which it just has. Okay. Now all I need to do is to plug a 0 into what's left on top, and I think you can see that the limit is going to be 3. Okay, because 3 is the only constant that's left. 0 squared minus 3 times 0 plus 3 gives me a 3. Okay, so all of the algebra is designed to try to factor out a common factor. Okay, idea is to get a common factor that can be divided out. Okay, with all of these algebra things. Okay, because the thing in the denominator is usually a problem. The last one, number 6, if you take a look at that one, you can see that's also problematic because if I let t approach 0, I wind up with zeros in my denominator. Okay, so how do I deal with this one? Well, this one actually is a subtraction problem if you take a look at the expression in parentheses. So why not try to do the subtraction? Okay, try to do the subtraction. And what that requires is a common denominator, a least common denominator. Now let's take a look at these. I'm going to rewrite this under here. The limit as t approaches 0 of 1 over t is real simple. I can't simplify this. But let's factor this denominator, t times t plus 1. Okay? What you can see by the factored denominator in the second fraction is t is already in there. Okay? So this denominator is bigger algebraically than this one because it has t as a factor. And then it has this other factor, t plus 1. So I'm going to use this as my least common denominator. Okay, because t already fits into it. All right, so how do I rewrite things then with that common denominator? Well, you might remember you have to take your first fraction, that's the one you want to make have the common denominator, and you need to multiply the bottom by t plus 1. But because you don't want to change the value of the function, you need to multiply the top by t plus 1 as well. Okay, this is just a fancy form of 1, t plus 1 over t plus 1. So you're not changing the value of the fraction. We're just giving it a common denominator. Second fraction stays the same. Okay, so I'm getting a common denominator here. Once I have a common denominator, I can do the subtraction up in the numerator. Okay, so that's t plus 1 minus 1 over t times t plus 1. Okay, so it was 1 times t plus 1, that's t plus 1, minus the 1 in the second numerator. Okay, gives me this. Remember, once I have common denominators, I can do the adding and subtraction in the numerator. Okay, well, I think you can see that the plus 1 minus 1 factors out. So this gives me t over t times t plus 1. And now I can cancel out the t's, which leaves me a 1 up here and a 1 down here. So I have 1 over t plus 1. Okay, now I can take the limit of this without a problem as t approaches 0 by just plugging it in. I okay? Just plugging it in. Okay, let me do it like this. Okay, that's going to be equal to 1 over 0 plus 1, which is 1. Okay. Here, I had to do some subtracting to get rid of the t that was problematic in the denominator. Okay, here I just pretty much had a factor. Okay, so you'll either need to factor polynomials or add, subtract algebraic fractions. Okay, there's another example that's not in here that would require you to rationalize a square root. But again, these are all intermediate and college algebra skills. Okay. So anybody questions on 4 through 6? Anybody questions on those? The algebraic limit ones? Okay. All right. Now, again, like your other exams, there are going to be questions that are not just calculation questions. There are going to be questions that you might have to answer true or false. There might be questions where you have to explain. Okay, please answer the explain questions. Okay, I'm noticing that sometimes on the exams, folks just leave those out. Okay, don't leave them out. They're for points. Okay, I have to manually grade them. Okay, based on your explanation. Okay, so here's an example of something that could be an explain question. Okay, true or false? If the domain of a function is negative infinity to positive infinity, and the limit as x approaches 2 of f of x is 6, then f of 2 must be 6. Okay, and then this would be something true or false. That would be the first part of the question. You'd answer that. And the second part would be explain your answer. Okay, so I'm going to let you think about that one for a while, just a minute. And what I'm going to tell you is try to think of a counter example. Okay, a counter example is one where these statements are true. Okay, so the domain is all real numbers, and the limit as you approach 2 is 6, but the function value isn't 6. See if you can think of an example like that. Okay, see if you can think of an example like that. Give you a couple of minutes to think about it, and then I'll ask you what you think. Okay, so what do you think about this? Do you think number 7 is true or false? Okay, I'm asking for feedback. What do you think? Is number 7 true or false? Just type T or F in the chat. What do you think? Okay, got a couple of trues. I got a false. Okay, most of you think it's true. Okay, that's valid. Did you think of anything that could be a counterexample? Okay, so what I'm saying is the domain is all real numbers. Okay, so let me see if I can draw a function that looks like that. All right, that's pretty simple. Here's a function whose domain is all real numbers. Okay, the way I've drawn it. Okay, and I want to draw it so the limit as x approaches 2 is 6. Well, let me draw it higher up than that then. Sorry. Let's put some markings on here. Let's make this 6. And I guess I should probably try to go through that point. So let me flip my curve around. All right, so how about like that? Okay, so there's a domain of all real numbers. And let's say the limit, I'm going to fudge my drawing a little so it looks a little bit better. And I'm going to make it right here. Okay, and it looks like the limit is 6. And you're telling me the function value has to be 6 as well. Okay. Certainly the way I've drawn this, it's true the way it's drawn. But couldn't I draw it like this? What do you think about that graph? Anybody have any feedback here? Here what I have is I have a domain, negative infinity to positive infinity. The limit as x approaches 2 from either side is 6. Right? As I get close to 2 from this side, I'm approaching y equals 6. As I get close to 2 from the right side, I'm approaching y equals 6. But what's f of 2? Okay, so this is called a counterexample. Right? All you need is one of those. Okay, if you can find one counterexample, and now I'm sure you're thinking of lots of other ones, right? Where you've got a hole in the function and some other function value, realize this function is defined for all real numbers. Okay? It's continuous up until we get to x equals 2, and then the function value at x equals 2 is 0. Okay, so there's a y value for every x. Yes? The limit exists, it's just not the same as the function value. Right? So whenever you get a question like this, think of discontinuities. Think of discontinuities, okay, to get a counterexample. All right, anybody have questions about number 6? 7, rather. Questions on 7? Anybody still not sure why that proves it? It can't be true for everything? Okay. Number 8. Okay, number 8. Find the equation of the tangent line to y equals 3x squared plus 2 at the point 1, 5. Okay, I'm asking you, how do I start this problem? How do I start this problem? Number 8. What do I have to do? Anybody have any thoughts? Okay, key word in the problem is tangent line. Okay. All right, Nee is saying, let's take a derivative. Why is that? Okay, why? Yes, she's right. Take a derivative, but why? Okay, to find the slope of the tangent line. Okay, good for you. The derivative at 1, 5 will give the slope of the tangent line. Okay, add that. Okay, and the first thing you need, okay, in order to build the equation of a line is its slope. The other thing you need is a second point. Well, you have that right here. They gave you a point. So you have enough to build the equation of a line. Okay, so what I'm going to do is find y prime. Okay, so I'm differentiating 3x squared. I'm going to use the power rule. So I've got the 3, pull that through, bring down the exponent, drop the exponent by 1. Okay, that gives me the derivative. The 2 does not give me anything in the derivative because the derivative of a constant is 0. Okay, so my derivative is 6x. All right, now evaluate it. Okay, there's no y value to plug in, but I can plug in the 1. Okay, so my slope is going to be 6 times 1 is 6. That's the slope of my tangent line. The next step is to use the pattern y equals mx plus b plus m value and 1 comma 5, where 1 is the x, 5 is the y. Okay, and then solve for b. Okay, you have everything else, so all you need to do is plug this stuff in and solve for b. Okay, so I have y equals 6. Well, actually, I have to put my y value in, don't I? Okay, my y value is 5. 6 times 1 plus b. Okay, so I'm basically taking the 1 comma 5, plugging it in for x and y. Right, then I'm going to subtract 6 from both sides to get negative 1 equals b. Okay, so I'm just subtracting the 6 here and here. All right, so my final equation is y equals 6x minus 1. Okay, y equals mx plus b. Okay, this is kind of a blast from the past. It's kind of a reminiscent of stuff you did in introductory algebra, where you learned how to find slopes of lines and things like that. You used algebra for that. Here we're using calculus because, okay, the derivative of a function gives you the slope of a tangent line to that function at a certain point. Okay, so that's the calculus piece. The rest is all introductory algebra. Okay, so questions on number 8. Questions on 8. Okay. The next bunch of questions, 9 through 15, and I think I'm going to try to get through 15, and maybe we can do one more if we have time. Okay, so I'm going to try to go through the next of them. The next batch of questions all involve using the rules for differentiation. Okay, 9 through 15 all involve using rules for taking a derivative. These are on your cheat sheet. Okay, or feel free to make your own cheat sheet. Okay, like for example, I might even put up here product rule. right? And I could say, okay, and again, everybody has slightly different flavors of these. Okay, quotient rule. Okay, and then again, chain rule is in there too, where you take the outer function, inner function. Again, you can write them on the top so you have them handy, have them on a separate sheet, whatever. Okay, so now you might remember chain rule used for compositions. Okay, so you have all your notes. Right? It's more important to be able to recognize which rule to use. Okay, once you know what rule to use, actually putting it into practice is pretty straightforward. Like for example, here I have a polynomial inside a polynomial. It's a cubic inside of a cubic. Okay, it's a composition. How do you tell? You have some function inside parentheses raised to a power. Okay, so I know I need to use the chain. Okay, so how do I do that? Well, first I'm going to take the derivative of the outside function. Okay, that's the thing raised to the third power. Bring down the exponent, leave the inside alone, drop the exponent by 1. All right, so here's my outer function. And then the chain rule says take the derivative of the inner function and multiply it. These need to be in parentheses, folks, because you're multiplying both entire quantities together, and they have more than one term. Okay, so if I differentiate the inner function here, that's going to give me 15x squared minus 2. Okay, this is the inner function. And you can leave it like that, all right? If you look at the answer key, they may have done some more simplifying. They may have multiplied one or more of these by the 3. So this would become 45x squared minus 6. Okay, the simplification is optional. Okay, everybody good with this chain rule? Okay. The next one is one where you have to rewrite the roots with fractional exponents. So you can use the power rule. Okay, another thing you might want to have handy, and it's in the course, are the rules for exponents. Okay, fractional and negative exponents. Okay, remember, roots are fractional exponents. Okay, you have whatever the root number is, like a square root, that would be in the denominator of your exponent. So r of x would be written as x to the 1/2. That says take the square root. Okay, here I have a cube root of something raised to the 4th power. Okay, the power is in the numerator of the fraction, and the root is in the denominator. So this would give me a 4/3. But it's also in the denominator here. Okay, so it needs to be negative. Okay, you need to be able to do that. Okay, now that I've rewritten these both with fractional exponents, I'm in good shape to just use the power rule over and over again. Okay, anybody questions on the exponents? Okay, taking the derivative, I'm going to bring down the exponent, drop the exponent by 1. Positive 1/2 minus 1/2 gives me negative 1/2. Okay, bring down the exponent, drop the exponent by 1. It's already negative. Okay, so I'm subtracting another 3/3 from negative 4/3. Again, use your calculator if you're not comfortable with this. If you wanted to rewrite this without the fractional exponents, you would have 1 over 2. The exponent on this x is a negative 1/2, which means it's a square root, but it's in the denominator of a fraction. Okay, this is 4 over 3. Okay, this also has a negative exponent, so it's going to be in the denominator of a fraction. The root is a cube root, and the power is 7. So it's the cube root of x to the 7th. Okay, that's if you want to rewrite it that way. And again, how do you decide? Follow the directions. If they don't say rewrite it without fractional exponents, you're good. Just leave it like that. Okay. If I look at number 11, I see I have a product, right? I have a linear 2x and a log ln x. Okay, you need to recognize it as a product of two functions. All right, so then I'm going to go to my product rule up here. All right, so I'm going to let u be 2x, v be ln of x. Okay, u prime is just 2, right? Again, bring down the one that's the exponent on x, drop the exponent on x to 0, and it becomes a 1, right? So x disappears. Okay, the derivative of ln of x is 1 over x. Again, that should be on your cheat sheet. Okay, and then I have my product rule. Okay, and I'm just going to copy it down like this, and then just plug the stuff in. Here's 2x, here's v prime, here's u prime, here's v. Okay. You might notice that you've got x's that cancel out here, so this can be simplified as 2 plus 2 ln x. If you want to do that. Okay, I guess I should, simplify if I can. Okay. Again, I'm assuming if you have a question, you're either going to pop it in the chat or you're going to unmute and ask. Okay, that'll speed things up if I don't have to ask everything okay with this one. That's a product rule. Here you can see I have 2 terms in my denominator, so it doesn't buy me anything to split this up as, say, a difference or anything. I can't do that. So here I have to use the quotient rule. Okay, quotient of 2 functions. And again, I've got that up here. Okay, so I'm going to let u be x, v be 1 minus x squared. U prime's easy, it's 1. V prime, okay, the only thing I'm going to get anything from is that negative x squared, so that becomes negative 2x. And g prime of x would be v times u prime minus u times v prime over v squared. Okay, and again, it doesn't matter what order you do these in. You can say, u prime v minus u v prime. Okay, it doesn't matter. Okay, it's v has to be first here, though. Okay, so I'm going to put my v in, and then my u prime. minus my u, which is x, and my v prime, all over v squared. Okay. And I think you can see there might be a little bit of simplification that can happen in the numerator up here. Okay, this is 1 minus x squared plus 2x squared. Okay, so this is going to give you 1 plus x squared over 1 minus x squared squared. Okay, again, for most problems, our homework and our test taking system won't have a problem if you don't simplify. Okay, it's just, this is super easy to simplify, so I did. Ready? Okay, number 13, I see a radical sign in there, so I'm going to rewrite this. So it's in parentheses instead of in a radical. Okay, to the 1/2. And now it looks like something in a parentheses. It looks a lot like this first problem up here. So I'm going to say use the chain rule. Okay, it's a composition. What is it? It's a polynomial, a quadratic inside a root. Okay, so I'm going to use the chain rule. Okay, so first I'm going to differentiate the outer function, bring down the exponent, leave the inside alone, subtract 1 from the exponent. That's my outer function. And then I take the derivative of the inside function, which is just the 3x squared, right? Because 4 is going to give me a 0. That's going to give me 6x. Okay? And you can walk away and leave it at that. Or if you notice, hey, I have a 1/2. So I can write that as 1/2. The 6x is in the numerator. Okay? And the square root is in the denominator. How did I know that? Well, the exponent on it is negative, so it goes down there. Now I think you can see you can factor out a 2. And this becomes 3x over 3x squared plus 4. Okay, I'm doing a little bit of simplifying just so you can see that these answers match what's in the solution key. A lot of the answers in the solution key are completely simplified. Okay, and again, you shouldn't have to simplify in more. Let's put it to you this way. If you do your work on paper and you get to this point, okay, and you put it in and it marks you wrong, I will give you full points. Okay, I will give you full points for unsimplified correct answers, as long as you show work. Okay? So show me your work and you don't have to simplify, okay? It should give you credit for it, okay? Because it's set up in such a way that if it's algebraically the same, it marks it right, okay? I did not write all of the more questions myself, so I don't know exactly how they're set. Okay, but I know I'll give you credit. All right, number 14, we're coming down the home stretch for today. Okay, here we have an exponential. Okay, and you might remember, hey, e to the x, that's an easy derivative. It's the same thing, except here we have a quadratic inside an exponential. It's a composition. Okay, so we need to use the chain rule. Okay, we need to use the chain rule because we've got a composed function. Okay, so h prime of x, we're going to start by repeating the exponential function because that's how you take the derivative of an exponential. It's itself, right? That's the outer function. And now I need to multiply that by the derivative of the inner function. That's the quadratic that's up in the exponent. It's inside the exponential, right? It's where x should be. So the derivative of that is negative 2x. Okay? Everybody okay with that one? Everybody okay with an exponential composition? Okay. Next, we have a log composition. This is a fourth degree or a polynomial inside log. Okay, use the chain rule. Okay, polynomial inside log. Well, you might remember the way you take the derivative of log, it's 1 over its argument. Okay, so let's do f prime of t equals 1 over 3t to the fourth, right? And then that's the outer function. And then I need to multiply that by the derivative of the argument to log. That's the inner function. Okay, so that's going to be 4 times 3 is 12t to the third. And that's up in the numerator. Okay, everybody see that? You might be able to tell that you can simplify this a lot because 3 goes into 12 4 times. Okay, and you can divide out 3 powers of t here. So this simplifies to 4 over t. But again, as long as you can get to this point, I'm good. Okay, just remember, this is upstairs, this is downstairs. Okay. All right. I think I'm going to end with number 16 and we can start with number 17 next time. So I'll put a mark here and say start here on Thursday. Okay, let's see if we can do number 16 though, in the time we have left. Find the equation of the tangent line to the curve, this, at the point 2, 1. Now this is a lot like the question we did before. Okay, the only difference is this is not solved for y. Okay, so what do I have to do? Somebody tell me, what do I have to do? What do I have to do here? Okay, I know everybody's thinking I got to take a derivative, but how? Reverse it, y equals equation first. You can't solve this equation easily for y. Anybody have any idea? You can't easily solve for y because of the xy term. And you'd have to take a square root. You'd get a positive, negative square root. It's messy. Okay. Can you differentiate it as it is? Hmm? Treat y as a function of x and use the chain rule. Everybody remember, treat y as a function of x and use the chain rule. It's called implicit differentiation. implicit differentiation. Okay, so every place I see a y, okay, I'm going to treat y as a function of x, and I'm going to have a dy dx. Remember that? But some things are complicated, right? The x squared term's easy. That's just going to differentiate normally with respect to x. This term in the middle, the 4xy, is a product of two functions. It's a product of 4x and y, which is a function of x that I can't solve for. Okay, so this is a product. And here is a composition. It's a function y squared. I can differentiate the outside, and the derivative of the inside is dy dx. Everybody remember this? Remember this, dy dx? Okay, let's attempt to differentiate it the way it's written. Okay, and I'm differentiate with respect to x. Okay, and y is a function of x. Okay, so I have to use the chain rule. All right, let's get started. Okay, if I take the derivative of x squared, that's just 2x. That's easy. If I differentiate 4xy, okay, this is a product. Okay, and I can do it like down here. Say u equals 4x, v equals y, u prime equals 4, v prime. The derivative of y is 1. That's the outer function. And the derivative of the inner function is dy dx, because I can't see it. Okay? And then I have my u times v prime plus u prime times v. Okay? And that's going to be 4x times dy dx plus 4y. Okay? So here's the derivative of the product. Okay? The last term is just y squared. It's a composition. So I'm going to first take the derivative of the outside of it. That's 2y. And then I'm going to multiply that by the derivative of the inside function, which is dy dx. So you can see all of the terms that had y's in them generated a dy dx. This one generated multiple terms because I had to use the product rule. Okay, and again, that was from that term that's highlighted in blue. Okay. The right-hand side of my equation is 13, right? So if I take the derivative of it, that gives me a 0. Okay, so then I have to collect dy dx terms on one side. Okay, they're all on the left already. Okay, so that means the non-dy dx terms go on the other side. So I'm going to subtract a 2x and subtract a 4y. That's going to give me 4x dy dx plus 2y dy dx. That's on the left. And the other two terms without dy dx wind up on the opposite side with negative signs in front of them. Okay, then factor out dy dx. Four x plus 2y minus 2x minus 4y. And the last step is divide by the parentheses, right? The quantity in parentheses. So that gives me dy dx minus 2x minus 4y, 4x plus 2y. So there's my derivative. Okay, but remember what they wanted me to do, come up with an equation of a tangent line. Okay, so I need to evaluate this dy dx at the point of tangency 2 comma 1. Okay, so that means x is 2 and y is 1. Okay, I can bring up my TI-84 to do that real fast. Let me share that with you. Okay, so I have a fraction. I'm going to use my fraction template, so I don't need extra parentheses. I have minus 2, and then my x value is a 2. Minus 4, and my y value is a 1. I'm just showing you that I'm taking this expression and I'm plugging in x is 2, y is 1. Okay, in the denominator, I have a 4 times 2 plus 2 times 1. Okay, and that gives me a negative 4/5 as my slope. Okay, and again, I have y equals mx plus b. So I'm going to put in my y value, my m value, and my x value. Okay, you can see what I need to do is I need to add this quantity to the 1 over here. So I have 1 plus 4/5 times 2. Okay, that gives me 13/5. That's my b value. Okay, so my equation then is y equals negative 4/5 x plus 13/5. And again, you can see how I leveraged my calculator to do the algebra. Okay, if you use your fraction template, which is alpha y equals numerator denominator, you don't need to mess with extra sets of parentheses. Okay, so it's real easy to do that. Okay, questions on 1 through 16? Anybody have questions on number 1 through 16? Okay, I'm going to come back to the meeting. Anybody have questions? Okay, you're also welcome if you want to bring your own questions.